A very good morning to one and all present here. I take an immense pleasure to welcome you all for the second day of the National Seminar on Emerging Trends in Construction Industry. A special note of welcome to our guest speaker today, Dr. V. Rajesh Kumar, Chief Engineering Manager and Head Geospatial Technologies, Water and Effluent Treatment IC, Larsen and Toubro, Chennai. Welcome you, sir. So for today's session, the second day morning session, we have with us Dr. Rajesh Kumar. So I'll just give a brief introduction about him. So Dr. V. Rajesh Kumar is a competent civil engineer with an eventful, versatile career comprising both academic and administrative experiences of more than 19 years, started with professional brilliance in executing and commissioning multifaceted projects with professional competencies in mobilizing and judiciously managing resources with structured inputs in the domains of teaching, research, industry, and administration to ensure accomplishments. So he has graduated from RVS College of Engineering and Tech Digital, and he has done MTech Remote Sensing from CET Guindy and then PhD from Sastra University. He has held all the responsibilities from lecturer to principal at various engineering colleges, the Dean and Professor, School of Engineering, Lovely Professional University, Punjab. Now he is the Chief Engineering Manager and Head Geospatial Technologies, Water and Effluent Treatment IC, LNT, Chennai. So he has a lot of publications in his name. So he has a book publication and almost 30 plus conferences and journal publications. So he has also guided PhD students also. He is a proud winner of awards like Best Educationalist Award, Rajiv Gandhi Educational Excellence Award, Best Influencer Award. And he is also a member of a lot of academic and professional societies. I welcome you once again, sir. I thank you for taking your time to come here. Uh, you may take the session now. Thank you, sir.
Thank you for introduction. A very good morning to all viewing this webinar. Firstly, I thank the management of LNT, our heads, Mr. Rajivan, Mr. S. Ramasubramaniam, and my geospatial team of EDRC VETIC at LNT for encouraging me to deliver this presentation. I thank the management, principal, civil department, and coordinators of this national seminar of Sri Venkateswara College of Engineering for giving me an opportunity to present this webinar. A special thanks to Dr. Kumuda, Professor and Head Civil, for making this webinar possible. So let me step to the topic, role of geospatial technologies in water industry. Here we shall see how GIS is becoming a successful implementation in industry nowadays with the following agendas. So like one, first I shall present a quick intro, then secondly, gist of remote sensing and GIS for those who are new to these topics. Third is the scope of geospatial technologies in water industry, the two particular in water industry alone. Then next, fourth is about our L&D. The last agenda will be like implications of this technology in our company. Here in this presentation, my main emphasis is listing on how we use GIS in our company. Many of us, while studying, think that GIS is a drafting software, and moreover, it is not used in the construction industry. But now, with a move to digitalization, the taste of GIS makes the company to use this technology for bringing the reality as a model in viewing. So we shall move to less theory aspects and mainly the applicative parts. So here we are seeing overview of geospatial technologies. The geospatial technology means emerging field of study that includes GIS, that means Geographic Information System, remote sensing, uh, remote sensing, and global positioning system. So geospatial technology enables us to acquire data that is referenced to the Earth and use it for analysis, modeling, simulations, and visualization. So here we can see a line like the signs of where. So this is the very important thing that we'll be using in geospatial technologies. Like generally when we are seeing about this GIS is a software which we are using in our company. So here the main motto of this GIS is like signs of where. It gives the positions. We'll see it in the upcoming slides. So in this slide, we'll see the overview of remote sensing. So remote sensing is defined as science technology of obtaining information about any data on the earth without touching or reaching that place. Simply, we can say, so when we are viewing through our eyes, eye is the sensor to capture the data without touching the object. So remote sensing is seeming to be simple always, but the processes are complicated to know enough. There are two different processes involved. One is data acquisition. The second one is data analysis. In data acquisition, the electromagnetic wave interactions, due to this electromagnetic wave interactions, the sensors receives the energy and convert to data which may be called, and it will be converted to data which may be called aerial photographs if we are if we are taking those photos through aerial photogrammetry, or it is called as satellite imageries if that the same thing is done, remote sensing is done through satellites. In the second step, data analysis, we can convert the data into useful maps or need based, which is called information. Here, mostly used technology is GIS again. So, in this slide, we'll see Geographic Information System, which is GIS, generally called a GIS, where G is geographic, I is information, and S is system. So basically, when this GIS is coined, so it is coined for this specific significant reasons. Like G is for handling spatial and non-spatial data. Spatial data means the data that define a location. For example, latitude and longitude of any point is called spatial data. And non-spatial data means one more example I can give. Our building lies at a latitude longitude, so latitude longitude will be a spatial data, and that building is a non-spatial data. Why? Because we can destruct the building and we can go for a new building in the future, but that latitude and longitude values will not change. Anything which will not change throughout years is called spatial data. And anything which can be changed, like temperature will be changing, color will be changing, so anything will be, rainfall will be changing, so those values are called as, those themes are called as non-spatial data. The second for I we are saying as information. So information means processed data. So I can give an example of a triangle. So you take sides of a triangle, or even our trilateration or triangulation. Generally, in triangulation, we'll be going for triangles. So in that, we'll use some techniques called trilateration, also using our instruments, survey instruments. So we can take the lengths of each side of triangle independently. So those are called as data always. When it is independent, it is called data. If you want to take the area of triangle, Then we will be using some formula like yeah, area is equal to root of s into s minus a into s minus b into s minus c, where a, b, c are length of the sides of triangle. So if area is calculated, that depends upon all the three sides of a triangle. So that is called information. So process data is called information. And the third one is system. Yes, system is collection of methods or objects to achieve a specific objective. For example, if you need addition, you want to if you want to go digitally, you need at least a cell phone or uh, a laptop or a computer. So put together everything put together, if it is achieving a specific objective, then it is called as system. So GIS coins all these three words like geographic information and system. This is a small brief of a geographic information system. So with all these things, a specific definition is available for GIS. GIS is a technology to store and manipulate data as per our requirements. This was developed as a software, and this have variety of applications. Earlier, we started differentiating AutoCAD and GIS since an impact was developed, both are same. But only on theory, we are coming to that point nowadays. Else, the differences are vast. GIS only makes us feel where we are on the earth. I told science of where. So this one. So where we are on the earth, whereas others make it quite complicated. GIS only link spatial data with the non-spatial data. So nowadays, AutoCAD and GIS promoters are linking them for various users and avoid data redundancy. In our company, we use RGIS software, and starters can try with the open source software such as QGIS. QGIS is a software, and you can try with it. Next is GPS. So every one of us will know what is GPS. Even in our cell phone, we do have GPS nowadays. So it is a primarily navigation system for real-time positioning. These techniques overcome the numerous limitations of terrestrial surveying methods, requirement of intervisibility of survey stations, dependability on weather, difficulties in night observations, etc. So these advantages over conventional techniques and economy of operations make GPS the current most promising survey technique. So here we'll see how GIS is empowered in water industry. The applications of GIS are vast. They are used for surveying and data management, then for spatial analysis, then for progress monitoring, then for operations and maintenance. So their applications are really vast in our company, that to water industry nowadays. Generally, in survey, we'll be going for drones or GPS or lidar, so on. In case of data management, where the technology is used for collection storage like cloud database, querying as required, viewing multiple layers from single place. So the third one is spatial analysis. Here we'll do adding, removing, querying of different layers of map. Then some applications like hydrological applications, site suitability, groundwater analysis, digital elevation model, and contour creations also will be done. The next most important thing is progress monitoring. So this is generally done to avoid manpower visits to the site. Here the site engineer will update the work completion details from the site itself, which can be viewed by the project managers and the client, so cost control is avoided. This is one of the main application that we are doing in our company. So mostly for all the projects that is going on in our company, we are doing this because the higher management need not to visit the site frequently. and they can see everything what is going on in the site from the office itself. So as it's a procedure for cascading also in the company, it is very much used. The last one is operations and maintenance. This is one of the main application after completion of the project for queries as required, like leak. We'd have been laying the pipes, so everything will be going on after completion of the project. There may be some leak detections. So in case of that, we need to use GIS, and even now SCADA technique is also used along with GIS. So, but in since I'm specific with the GIS, I'm telling only about GIS. So we'll be seeing which pipe where it is getting leaked and where it is available. So the location of the pipe will be taken from GIS, and the engineers will go, and everything leakages will be taken off correctly. And one more thing I want to say here is lidar, the main technology for surveying. Mostly we are going for lidar. So lidar is one of the advanced surveying technique used in industries nowadays for numerous applications. When you want to classify lidar, lidar has three different classifications. One is static ground based, mobile based, and the third one is aerial lidar. So all these three we are using. um, is in case of static, we will not be going for what to say, a larger area, but it will be similar to total station type of instruments. In case of mobile based, the instruments are fixed in vehicles itself, and the vehicles will be moving, then the points will be captured, like we can say examples like highways, railways, Google Street data capture, etc. can be seen that. And the last one is aerial based. So aerial based means lidar instrument is fitted in aircraft or helicopter, and they capture all the predetermined along the predetermined hand and some speed to cover the area efficiently. Some of the advantages of lidar are like spatial accuracy, and we can complete it very quickly when compared to conventional type of surveys. And in the coming slides, we are going to see the works that has been encountered in our company. And we belongs to EDRC department, that is Engineering Research Department Center of Water and Effluent Treatment Company, that comes under L&T. A separate geospatial wing for our company was established some 3 years ago, and the highlights of the works done are coming in the following slides. So this is a sample which you can find in our official website as well. Uh, we have these many ICs, that is independent companies, that all comes under L&T building and sciences, but we comes under this effluent water and effluent treatment company. So this is also a sample that the offerings works that we are doing in our water and effluent IC. This is also available in website. So these are the broad classification of our involvement in different uh, project phases, like pre-bid, engineering design, execution, and operational maintenance. So generally, you can see contour map in mostly all the cases we'll be doing. Then we'll be creating digital elevation models and something called chuck delineation, so which is more predominant work in irrigation projects. Then we'll be in design phase, we again will be going for contour maps. Then we are creating a digital elevation models, then watershed delineations, because we need to draw the watershed at each point for calculation and for design purposes. And then data conversions, that's also very important here. Again, check delineations here also in tender stage also will do, and in operating stage also will be doing this. Then mapping of existing data, whatsoever data is available in the ground will be existing, and new data will be designs will be carried out based on that also. In execution stage, as already we have discussed, we are doing progress monitoring and as-built data creation. There is whatever we are building, whatever we are laying. If pipe laying means what pipes are laid and what is the diameter of the pipe, what is the length of the pipe, what is the material of the pipe we are using. So each and every data will be created. So as during O&M stages, when we there is some problem in the pipe, or if pipe is to be replaced, we need to know the correct exact details of the pipe, including diameter, so as we can replace it very easily. Else otherwise it will be very difficult if we are having only manual data in it. Similarly, map layouts as necessary we'll be doing, and like check delineation, this GIS BM integration, it's also prominent. It is very significant. It has been appreciated by all the clients whomsoever has given project to us. Then in O&M stage, we are doing billing app. For billing app, we are linking GIS to the billing app, so as how much of water they are taking per month will be metered easily. Then where asset management is also done. Then general simple supports are also done. So when we are completing the project cycle, then construction is completed, construction of layout, everything is completed. Then the most significant phase, O&M, is being taken care of by GIS only, because without GIS they can't get data, because the area which is taken under the project is very vast. Since it is very vast, so we need some voluminous a software which is handling the voluminous data. That software is our GIS. So we can handle any voluminous data. How many data you want, all those data can be uh, saved in GIS. So easily we can get what is available in that particular location. So we are doing contour preparations also, generally from open sources. This is zero point 0.5 meter contour uh, from open source. We have done Airbus data. This is also one of the contour generation that we have done it from SRTM data. This is also a contour, and this is check delineation. As I told in the previous slide, I told significant work has been taken care of in check delineation. So check is Punjabi word that denotes the land revenue settlement or assessment circle, marking a contiguous block of land. In due time, the term check became synonymous with the term village itself. In terms of irrigation, means that check is irrigated by branch of water course fed by a sluice channel in the bank of main channel. From the main channel, sluice channels will be going. That from that, check will be getting waters. So where the amount of water given to the check from the owner is in proportion to the area of the check. If this is the area of the check, so amount of water that will be given will be more. And if this is a check, then amount of water will be less. So based on this, they will be giving water. For major irrigation systems, it is wise to decide to know the number of outlet points. If pipe is coming like that and branches are going like this, so outlet points in each check will be having an outlet point. So that is to be decided. Um, that we in bidding stage also we will be knowing it. In GIS, we calculate the total area and split them into required area like 2.5 hectares or 20 hectares based on requirement of the client. So this is a sample work of chuck delineation, that is dividing the area into parcels uh, for a project. The project is this one, Ratnagar project of Madhya Pradesh. So this is also a chuck delineation. So for equal area, we have done it. This green or chucks. Next, most important work we are doing is watershed creations, that is delineation. So we know watershed is defined as any surface area from which runoff is resulting from rainfall is collected and drained to a common point like this. So runoff is collected and it's drained to a common point. So generally it is synonymous to drainage basin or this catchment area. A watershed may be only a few hectares in as in small ponds or hundreds of square kilometers as in rivers. So this is watershed creation that we have done for Bhavani Sagar Dam. We have used Astrodem satellite, open source satellite image. And moreover, all civil engineering engineers would have studied this Thyssen polygon, and we'll locate the satellite station, rainfall stations, and then we'll be drawing by hand by taking that's dividing into triangle, and then we'll be drawing. So that is very easily that if we know the lat long positions of satellite stations, rain gauge stations, we can very easily find out these and polygons. So as we can see the coverage of each rain gauge station. If rain gauge here, this is coverage of one rain gauge station. This is coverage of rain gauge station. So based on that, we'll be collecting rainfall data from weather department, and it will be utilized for design. Similarly, we are generating stream networks also with the already watersheds we have done, like with the stream networks necessary also we are doing. So this is to decide the best suit location of culvert based on the stream flow. The watershed has been modeled for this project, ISP Parvati project in Madhya Pradesh state. Using the input uh, road and contour, we have generated a stream network for the watershed like this. We can, I'll think we have one more slide on this. Yeah. The output of watershed with the streams. So everything is available. So this is three-dimensional representation the stream. I think you can see the three dimension here, 3D view. It's moving. The last slide that is shown in three dimensions. So if we are showing like this to the client, they'll get impressed, and we can see how the contour variations are there, and how streams are going. Everything we can see. Next, we are doing data management also, where we will be delivering the complete database of assets. Any database, as I already told the previous slide, we'll be adding all the data of this particular networks. These are the networks, and we'll add everything. For example, even walls, type of walls, chambers, joints, T-joints, or meters, everything, whatsoever is available, everything will be taken into this itself. After construction, the control, most of the control will be with the geospatial technologies only during this O&M stage. This also examples for our data management. This is a water treatment plant, and this is pipe networks in Google Earth map. So we have used this technology for flood level demarcation also, for effective decision making of flood level at the proposed weir. This is a weir construction in Bhavani River. The high flood level, crust level, and low level water level around the proposed weir has been demarcated. Here you can see, which is high level, everything you can see red. And the most important thing that when we are taking data from the departments, other departments of our company, we'll be getting images in raster data or in vector data or in CAD data, normal CAD data. So we need to convert that into GIS format whenever we need to work in GIS. Again, that is to be given to them in reverse, this vice versa format, like CAD format or image format or image to vector, raster to vector format, anything we need to do. So for that, we are using GIS. So using two GIS tools, we have converted the image file into design usable format. The old hard copy data can be converted into, like these old hard copy data also can be converted into digital database for effective storage and usage for any later purposes. This also some of the data conversions. GIS layer is converted into a CAD layer here. We are getting a GIS layer, then that is converted to CAD. So, but design team, those who are not having knowledge in GIS, they will be working in CAD itself. Then the main thing what we are doing is we that is called a consumer survey to know the number of consumers in particular area. So as the water demand will be calculated based on it. So then based on the water demand, pipe networks, pipe design will be carried out. So then it will be the work will be prosecuted. Here, data collection will be done in a standard format, uh, like a government would maybe having already, but some of the data which is not available, the government will be taken. We need to do it by different agencies, vendor agencies only. We are doing it. So after collecting the data, so we are creating this. This consumer, that is house built up, built up areas will be created from imageries or uh, drone, even drone survey also will be creating in whatsoever format. Even from lidar survey also we can take based on area. If area is more, then we'll be going for lidar survey. Else otherwise we'll be going for total session survey or GPS surveys. Generally in water sector, the estimation of urban water supply, wastewater are dependent on number of consumers mainly. For this, we are working with the nodal agency to understand the requirements. So here in this slide, you can see consumer survey layout. This is layout. Like this only we'll be preparing the layout, all our houses here uh, for Pune project. Then we also will link each house will be taken a photograph and the details of house will be there. So we are creating a map of consumer survey like that. If you're clicking at any house, we'll get the details like this. So in future also it will be useful. Even owner of the house will be there. Name of the owner of the house, contact number, everything. So if any problem is there from O&M office itself, they can call and they can inform them very easily. Then cadastral mapping. This also we are doing in most countries. Legal systems have been developed around the original administrative systems and the cadastre to define the dimensions and locations of land parcel described in legal documentations. These cadastral survey documentations will document the boundaries of land ownership by production of documents, diagrams, then sketches also will be there. Even in charts, maps also they will be doing it. This cadastral survey information is often a base element of geographic information system, that is our GIS, or land information system, that is LIS. We'll be shortly calling land information system as LIS. It is used to assess and manage the land and built infrastructure also. Such systems are also employed on variety of other tasks. For example, to track long-term changes over time for geological or ecological studies also we are doing it. So this cadastre is a fundamental source of data in disputes and even in lawsuits between landowners when problems comes, they'll be this will be used as a proof. And we are creating land use land cover maps also, which are very much needed for irrigation projects, because in case of cultivable non-cultivable land will be doing, and when pipes are when we are laying the pipes will be laid in generally non-cultivable lands only. So to define that, we need land use and land cover classification maps for particular area where we are doing the projects. And for approvals and permissions from government, if you have all the required data in GIS database, it is very easy to create the layout like this. This map is created for trial pits wherever we want to put trial pits, and then we have submitted to government, so as they will be seeing very easily, and approvals also can be sought very quickly. So this dashboard shows the borewell data collection progress in real time. Data collection team will go to each borewell site to verify the existing borewell data which is already published, and collect the new borewell data wherever it is not available using collector for ArcGIS mobile applications. This greatly reduces the human error in data collection and processing for data from site to office, as the data can be downloaded anytime as required. And estimation of excavation is challenging in irregular terrain, as the manual calculations require many approximations, like generally we'll be going for Simpson's one-third rule for volume calculations. It's called as Press model rule, or end area method will be going. So when the terrain is irregular, it is very impossible to use those procedures. So we'll be using GIS procedure. So GIS is capable of creating the actual terrain using the survey data, whatever survey data is required. Based on survey data, it will create the actual terrain, and the exact profile is created in 3D as per the plan, and exact quantity is estimated easily when it is needed for a complex terrain. This helps greatly, as the exact cost is estimated prior to the excavation itself, and subcontractors are finalized accordingly. So this is also contour to DEM. So contour to DEM, and uh, we have extracted the excavation profile lines with the levels in GIS, and creating surface of excavation profile also has been done. Then calculation of cutting volume fill using some tool called cut fill tool in GIS is available. Based on that tool, we are calculating this. So we can show how the pattern is changing, and what for we have found out the volume. Everything can be told using these methods. Then next thing which we want to know, the important thing which is very much necessary for our projects, most of the projects, is collector app. So this is for ArcGIS software. We do have ArcGIS software there, as already told. So for that we have a collector app, so which is used for this progress monitoring. During the progress or implementation of projects, the site engineers' inputs are very important, which is real time representation. So site engineers, as already I told in some other slides earlier, site engineers will go to the site. They'll be collecting the data and updating everything on end of the day. So but it can be viewed from our office itself. So for that, it is very much useful. This collector app is useful, and we are using this collector app only, so as accurate data will be available. So then, if you are updating in app, immediately it will be get connected with our software, and it will be updated in that also. So we are doing both 2D progress monitoring and three-dimensional progress monitoring also. This is a two-dimensional progress monitoring, where if you're clicking here, we'll be knowing how much work has been completed, everything. So all those details will be available in the legend also. And based on color shades, we'll be differentiating that this up to this length, the pipe is the laying of pipe is over, or excavating. Excavating that land for laying out of pipe is over, whatsoever the things may be, it will be very clearly known. This also progress monitoring. So we have four different progress work. One is excavation, other is pipe laying, other is hydro testing, the fourth one is backfilling. So all these things will be in the legend, and based on different colors, we'll be knowing whether which work has been completed in particular area, and what is the pending work available and when it will be completed. All these things can be calculated based on this progress monitoring site itself. This is a progress monitoring dashboard again. You can see here some examples like total progress. There is actual, it is actual value to 24,353 meter has been completed, and planned is 84. So zone wise also we'll be dividing the total area into zone, and in each zone how much is planned and how much it is completed. So if you're clicking on actual or completed, we will be getting the details like this. What all the details available, that also will be getting it. And this is the legend. Then as built, whatever pipe network we have completed, this will be taken using the collector app, which I have explained, and this will be updated. Even availability, so old data which is available also will be taken, and new data which will be constructed in real time also will be taken, will be updated in this network. So we are bringing everything into digital. As earlier, if there is some problem in our pipe network in from our home, it will be very difficult to see where the problem is and how pipes are going on. So all those problems will be there. But now, when we are moving to digitalization, we can easily see that using the software itself. From your house, if your house is here, from your house the pipe network is going, that will be available here. So when there is some leakage or any problem, then clotting is there, anything, we will be easily identifying it from where it is going, and rescue operations also can be very easily done for it. This is one very important thing that has been appreciated by our team itself, teams of company, other teams of company, when we have created this asset management data dashboard. So data only. So here, asset management means it is used to help the company to monitor and manage their assets in systemized approach. So like today, in this site, there may be this many assets will be available, and tomorrow, this site, these may be shifted to the other site. So all those data will be updated on daily basis. So you can see here. So work order cumulative, how much, and hire charges, how much we have hired. Some other equipments may be hired. Some other tractors may be hired. So all those values will be, it's for daily basis, it will be available. How much it has been used, what is the productivity. So all those details will be taken care of this asset management dashboard. This is one of the management dashboard we have created. And for construction in any steep terrain, the estimating risk of flooding is changing always. So thus, flood analysis is required in those cases, and will be done using hydrological modeling software. So we'll take help of hydrological department for this. So we'll give the inputs for the model, such as catchment areas, stream network, then digital elevation model, all will be prepared by us. We'll prepare everything and it will be given to them, and they'll use some hydrological software. Using that hydrological software, we'll be getting the output, and again that outputs will be viewed in GIS to visualize in three dimension, to see the impacts also, like this, how water is moving, what type of training works are needed, how we need to change the canals or rivers coming to us, that how it is to be trained. All those details will be taken care by this flood risk analysis. And so far, visual interpretation method, like visual interpretation method means we'll be seeing the imagery. From the imagery, by seeing the imagery, we'll be drawing the maps, and we state what is it, like a building or trees or a forest area or some other areas, pond or lakes, whatsoever it may be. We'll be doing it visually by seeing the imagery, satellite imageries. But what happens is, now we are using this deep learning algorithms in GIS to extract uh, extract the building footprints automatically. So we'll be giving some training sets. Based on the training sets, we will be getting all these things. So these are building footprints. That means houses. And next is the very important thing that we are executing in all the projects nowadays is GIS BAM integration. For that, I'll say what is BAM. BAM generally they are calling as BIM also now. It is Building Information Model. It's now widely used in all the construction industries now. But in all the industries, they have not integrated with the GIS. That we are the pioneers. GIS integrating GIS with BAM. L&T Wet IC is the pioneer, and we are doing it, and we have succeeded it also. So this is how we have done it. So three dimensions from, I told you no earlier when I was dealing about two-dimensional progress monitoring. Then we are trying for three-dimensional also. This is three-dimensional progress monitoring. So the Revit files, as design files, will be as such taken into here without losing even a single data. Like if they are having how many diameters, how many steel rods of this many diameters are needed, that also will be available in GIS. We'll be bringing everything. The problem is, whenever we are opening the map, easily you can open it in GIS. The same thing if if you want to open the Revit file only for a building or for a particular area, you can open. But we can show all these things. Staff quarters is there, some building is there, some sump is there. All these three dimensions can be shown here. So when you are clicking at each point, we'll be getting all the details here. So whatsoever details coming in BAM, there is BIM, and the details whatever needed after that also. Like earlier in two-dimensional progress monitoring, we are adding many details, many attributes. So those attributes also will be added here. So only I told you that the GIS will be helpful for storing voluminous data, any number of data, and it can be used for years. So now you can say today, even daily data also can be stored in GIS. That much capability GIS has. So this is also some of the views of a project, three-dimensional model with the design. So this is pipelines which are going, and maybe roadways. Sorry. This is a vertical slice, a building we have divided, and we are showing it in GIS itself. All these are in GIS platforms. So I can show some videos. So this is for a project in Abu Dhabi. Uh, During early design stage, we have created with the sample pipe network and Revit models to show how it will look like in the field. See, during the COVID situations, we are unable to visit sites in real time. To explain with reference to real time, we can use this space. We have used this only. This also can be used with augmented reality and virtual reality tools to enhance the user experience with this early stage of project. So we have created this, and already it has been shown to the client also. So this much advantages the GIS software has. Each and every pipe, how pipe networks will go, and where will be the treatment plant. So till treatment plant, it will be going. So everything can be shown. A small video we have created in GIS, and in small video we are showing it to them because they may not be having more time to see each and every steps there. How it is going. So we would have explained, the team would have explained to the client on this also. So what is red and what is yellow, what is blue. So all those things also will be explained. You see the plant there. So till that, how it will come, the shape. Since we have Revit models, it will be to scale only. So to scale, it will be shown in the ground itself like this using GIS. So again, we are showing the thing only. Since there is no time, I'll go for the next slide. So this is a complete visualization and database of a mega irrigation project. Here it shows from intake to distribution for about 4,300 square kilometer command area. This system includes, these are network, this system includes BIM data and GIS data also. In BIM data, we'll be showing the pumping stations and delivery chambers, whereas in GIS data, we'll be showing all the transmission pipeline, distribution pipeline, wall outlets, villages, chuck details, everything will be showing. Here we have done, since the area is too vast, we have gone for LiDAR data, and the accuracy of that is 0.1 meter. So that even inside what is available, so everything will be shown. In a small video of this much time itself will be showing everything. But when we want to go for operations and management and all, we need to show the full GIS data. We need to operate and work on the GIS data only. So again, it will be coming like this only. At last, it will be going to checks. These are checks. So all these networks, pipe networks. So even you see values, chainage values are also coming there. That's everything. Chainage values will be coming. So there is no need for us to create or save hard copy data if we are having all these things. So saving in hard copy and saying in hard copy is very difficult because how many hard copies we need to create if the area is this much vast, you see. So all those have been avoided because of these techniques. Next. So as I said earlier, aerial lidar, one of the interesting application of aerial survey, plus remote sensing, plus laser lights. This is a very important application what we are doing, and we have done it also for the projects. Usually, the volume of data collected in the lidar are very high, especially in case of aerial lidar. Also, the file format of the lidar would mostly be equipment specific. Hence, the same company lidar processing software would be needed to do initial pre-processing, and they can be exported to last format, that is lidar format, laser format. So in layman term, it's a PDF, like we'll be changing it to PDF format, and then it can be edited in many softwares. That also will be done. And here, this shows a sample picture of a project at Madhya Pradesh. Sorry. shows a sample picture of a project at Madhya Pradesh here. The data can be downloaded in ArcGIS desktop and ArcPro also. So here the classified point cloud loaded with the ArcGIS, and it's all for this processing. I mean to say simple words, it's processing of LiDAR data. And again, the topo maps, both cadastral and land use maps, created using LiDAR, and ortho map are also validated. This is very critical in pipeline routing always. So this is a recent survey we have done for a project site at Odisha, where we have surveyed only the pipeline alignment with a buffer of 30 meters on both the sides. This one, both the sides. So this gives us the precise levels and understanding about the terrain. This also helps in land acquisition when overlaid with the owner details. And the main important thing and last slide that I'm going to present in this webinar is about this file compression. The voluminous data from, for example, LiDAR is more. So for design software, it would be very hard to handle if because the values will be in GB, file formats will be GB. So what we'll be doing is we'll be converting the file into formats, into GIS formats through compression process. So when it is done when it is compressed, approximately some 60 to 70 percentage of the data size will be reduced. For that, we are using file compression. For example, here you can see the flow. We had a CAD drawing which cannot be opened, so we are converting to shape file, then again to tin, that is called triangulated irregular network. Again, this tin to digital elevation model, and then to mosaic contour. So this mosaic contour will be compatible with the Civil 3D software. When they are opening this CAD drawing, it is very difficult for them. But when they are opening this contour directly, and there is no loss of any data, accuracy will be as such what we have given through the survey. So no changes will be there. And so this is also mostly followed in our wet IC, water and effluent IC. And I think I've presented more slides here uh, representing the works that we have done in our wet IC. So most of you may like the presentation or may not be like the presentation because the works may be different. It's like what to say, it's a film only. So you may not be understanding it also, but time to go, you'll be understanding that too. Basically, a civil engineer has to has to go on with this remote sensing in GIS subject, and if possible, during your BTech itself, you can study this software also. If it is not possible for you to get ArcGIS software, because ArcGIS is generally costly, you can go for open source softwares. So like QGIS, QGIS will be user friendly and you can learn by yourself itself. Or some training programs are also available in net. Many of the training programs also available. You yourself can enroll it, and it for cost of 500 rupees or something only. You enroll it and do it. And even when you are coming doing your final year projects also, you try to implement it, because since there is a move to digitalization, all the projects they are requiring GIS and spatial softwares. Thank you for giving me opportunity, and if you have any queries, please send to this email. Surely I'll be replying it. Thank you. Thanks a lot. Uh, Thanks for giving me opportunity to present again. Thank you. Thank you.
Yes, sir. Thank you, sir. Participants, do you have any queries to ask now?
So even if you don't want to ask now, you can send me a mail. Surely I'll be replying it.
Okay. So thank you very much for this
Thank you.
wonderful session, and it was a very great presentation. So we got an overall view of the applications of this, and I'm seeing a lot of technological improvements in this software itself. So how the data is gathered, the spatial analysis, inferences, all that you have touched upon, and mainly the last few videos and all that, it just showed that how much digitalization and
Yeah.
all these subjects on deep learning algorithm, BIM, artificial intelligence, AR and VR, all that is important, because even in college level, we keep seeing that we have to revamp the curriculum based on all these technological needs. So it gave a very good picture on all that. So thank you once again, sir.
Thank you.
So,
Thank you.
yes, sir. So on
Thank
behalf
you.
of Department of Civil Engineering, Sriperumbudur College of Engineering, I thank you very much for this. Thank you, sir,
Thank you.
and thank you,
Thanks a lot.
participants.
Bye.